We're going to look at 6.6. Before we do that, let's go ahead and look at the warm-up. So go ahead and try this warm-up, put me on pause, and go ahead and try to solve it, and then see how you did with it. You guys have a choice. You can either do the distributive property and multiply the 3/5 through, or I would get rid of the 5 in the denominator by multiplying everything through by the LCD. If you do it that way, you have to multiply all terms, but understand that this term right here is one term. So these 5s are going to cancel, and you're going to end up with 3 times x plus 2 is equal to 5 times x is 5x, and 5 times -4 is -20. Now doing the distributive property without a fraction will make life easier. Subtract 3x from both sides, getting our like terms together. We end up with 6 is equal to 2x minus 20. Let's go ahead and add 20 to both sides. That will give me 26 is equal to 2x. Divide both sides by 2, and we end up with x is equal to 13. Systems of linear inequalities. This is lesson 6-6. Writing a system of linear inequalities using a graph. That part is cut off, I apologize. What system of inequalities is represented by the graph below? If you look at this, guys, let's look at the solid line first. What is the slope of the solid line? That would be this line right here. Well, the slope is the rise over the run. So if I start with this one, it would be up 1 to the right 1, up 1 to the right 1. So the slope is really 1 over 1, which is 1. The y-intercept is right here, which is -1. So the inequality is going to be y. I'm not sure if it's going to be greater than or less than, even though you can notice that from the blue line it's shaded above it. We have double shading, which is very confusing to look at, but it's going to actually be greater than or equal to, because it's a solid line. We can check with our checkpoint to be sure, but let me finish this one up. So it's my m, which is 1, x minus 1. So let's do a quick checkpoint on this, which is 0, 0. If I check this to make sure it works, is 0 greater than or equal to 0 minus 1? Is 0 greater than or equal to -1? Yes, so shading above my solid line actually works. So that is the correct inequality. In the second one, the dotted line, which is this red one right here, the slope, let's figure out what it is. It's tilted to the left, so I know it's going to be a negative. It's going to go down 1 to the right 2, down 1 to the right 2. So down 1 to the right 2. So my slope is -1/2. My y-intercept is right here, 1, 2, 3, 4, 5. So my inequality, and understand the dotted line looks like it's shaded below it because you can see the yellow over here in this area. So it looks like 0, 0 is going to work. I'm thinking because it's shaded below, it's going to be less than, can't have the equal sign because it's a dotted line, -1/2 x plus 5. Let's make sure we're right. Putting in 0, 0 into the inequality I just wrote would be 0 is less than -1/2 times 0 plus 5. Is 0 less than 5? That is true, so that means that this side is the true side, and shading down was correct. Name a point in the solution right here. Well, that's any point that's in double shaded region, and that would be this area right here, S for solution. So you could name any point, like 0, 2 would be a point. There's infinite number of answers in here. -2, 0, -2, 2, etc. All right, graphing a system of inequalities. Remember, if it's a dotted line, it just has a greater than, less than. If it's a solid line, then you have to have the equal sign included. When you graph a system of inequalities, which means two or more, you're going to graph both linear inequalities on the same graph like you did before with regular equations. And then the only thing that's different here is you're going to put a big S, which stands for solution for both. That's where it's actually double shaded. Guys, be very careful when you do this, where you look for the S, because the shading where it's being doubly shaded is sometimes hard to figure out if you get too carried away with your coloring. And you're going to need graph paper, so put me on pause and go grab some graph paper. Alright, so here's our example. It says y is less than 2x minus 3, and 2x plus y is greater than 2. Excuse me. If you look at the first inequality, this one's nice for us because it's already in slope-intercept form, so my slope is 2 over 1, and my y-intercept is negative 3. So let's go ahead and graph that one. Starting at negative 3, which is right here, and I go rise 2 to the right 1. Rise 2 to the right 1, or I could go down 2 to the left 1. It does not have the equal sign, so that means we're going to connect it with a dotted line. So grab your straight edge. We need it to be dotted. And go ahead and draw it all the way through your graph from end to end. Don't forget to label it. Y equals 2x minus 3. The second part you have to do is the checkpoint. So I'm going to do the checkpoint up here, and we're going to check 0, 0. And you're going to plug that in to see if 0, 0 comes out as true side or false side. 0 is less than 2 times 0 minus 3. Is 0 less than negative 3? That is false. So that means 0, 0 is false. So I'm going to put an F where the 0, 0 is, on the side where 0, 0 is, and I'm going to put a T, which has to be the true side, on the other side. Don't forget, you always shade the true side. So that means that you start at that line and you shade only the true side, which is below that line. Do not get carried away coloring this, because we have to shade or graph this line or an inequality, and we have to graph or shade that as well. So it's going to get a little bit confusing. You can use x and y intercepts, or it might just be as easy to subtract 2x from both sides, get y is greater than negative 2x plus 2, which gets it into slope-intercept form. M is equal to negative 2 over 1, and b is equal to 2. So that means we start at 2 on the y-axis, and we go down 2 to the right 1, down 2 to the right 1, and keep going until you get 4 or 5 points plotted. We know that it does not have an equal sign in it, so that means that we are going to connect it with a dotted line, like so. Don't forget to label it, which is 2x plus y is greater than 2. Now we have to do our checkpoint, which is going to be 0, 0. That's going to tell us, be careful, we're looking at this line right here, the green one. Is 0, 0 true, or is this false, this point? So we end up doing 2 times 0 plus 0 is greater than 2. Is 0 greater than 2? That is false. So if you go to your green dotted line, this side is false because the point 0, 0 is on the false side from this, which means the other side of that green dotted line must be true. Therefore, when we go to shade, we have to shade the true side, which is this side. Keep it neat. because now it's starting to overlap, which starts to make it look confusing. Now, a lot of times when you guys graph inequalities, they're not going to intersect at an exact point like equations. That's okay, because really your solution is where the two overlapping shaded area, or the shaded overlapping area is. So now we're going to draw a big S. Let's see, I'm going to do highlighting mode. Let's draw a big S for anywhere it's doubly shaded. There's no shading here. There's one shading area here, one shaded here. The S is right in here. So I'm going to draw a big S. That S represents all the points in here work for both inequalities, whereas all the points out here work for none. The points in this little triangular area work for only the green dotted line, and the ones over here will only work for the pink or orange dotted line. Alright, this one's actually pretty basic. It looks a little confusing. You're going to end up needing 3 inequalities. You're planning on what to do after school. You can spend at most 6 hours daily on basketball and homework. You want to spend less than 2 hours on basketball, and you want to spend at least an hour and a half on homework. What is a graph showing you how you can spend your time? So let's go ahead and let x equal the number of hours for basketball. And we'll let y equal the number of hours for homework. So that means the 3 inequalities are going to be in here. We're talking 6 hours, whoops, we're talking about 6 hours basketball and homework. We're talking less than 2 hours for basketball and at least an hour and a half on homework. So those are actually our inequalities. So we're going to have 6 hours of basketball doing, oh, I'm sorry, at most. We don't want to forget that part. That's the inequality part. So you're going to have, the total number of basketball, which is x, plus homework, y, has to be at most, so less than 6 hours. That's the first one. The second one is less than 2 hours for basketball. So basketball was x. So x has to be, the number of hours of basketball has to be less than 2 hours. Then the number of hours on homework is at least, so y, number of hours on homework has to be greater than or equal to 1.5. So when we go to graph this, which you really should do it on graph paper, but because I'm running out of time on the video, it's going to look something like this. You really need your first quadrant actually, because we wouldn't have negative hours spending on basketball or homework. So this one's actually, this one, the first one, you'd have to solve for your x and your y, or your y, which would be negative x plus 6. So your y-intercept would be at 6. And you have to go down 1 to the right 1, 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 down 1 to the right 1. So when you connect that with a line, it has to have a solid line because it's got the equal sign. It would be something like that. X is less than 2. That's on the x-axis, which is right here, which is going to be a vertical line. So let me go ahead and see if I can ballpark this. Oops, I made a mistake. Do you know what it is? It has to be a dotted line. And then the other one has to be a solid line. I have to remember to go back and shade because I didn't actually do that. 1.5 would be roughly right about here. See how confusing it gets when you draw more and more lines? I'm going to get cut off here, guys, but you're going to end up having to shade, which is